This recording is for Mrs. Dudo's class. I would like the substitute to please pause the video at this moment and pass out the Quick Check 5-4. Students will be allowed to work on this for 10 minutes, and after 10 minutes they need to turn it in, or if they complete it beforehand, turn it in before the time runs out. So please pause this video for 10 minutes in order to complete the Quick Check 5-4 and turn it in. Once you've completed it, start the video up. This is the recording for topic 5-5, making connections. You can describe relationships for given problem situations and write equations. That has been our objective for quite a while, and we're going to continue with that. I want you to use this objective to write your essential question at the top of your notes. Today we're going to be making connections between the tables, the graphs, writing the equations, and a verbal description. So each day we have concentrated on one of those particular things. Now we're going to do all of them. Looking at the first problem, we are given a table, a graph, an equation, and the verbal description. The one area that has everything filled in for us is the verbal description, so we will start with that information and see how we can use it in order to create or fill in the rest of our information. The verbal description says an electrician charges $45 per home visit plus $20 for every hour he spends working. So we must come up with an equation in order to match that description. When we write our equations, remember we are looking for our output equals to our beginning, and then are we going at a positive constant rate of change or a negative rate of change? Is it changing in a positive direction or a negative direction? And that is going to be multiplied by the input. One of the things that you can tell in our table, look at our table, that gives us an input and an output. So we know in this situation our input is hours and our output is the cost. Actually, I'm going to go up here and label. Here's our input. This is our output. Knowing that information, we can look at our graph and we can label our X and Y axis. Our X is the one that goes left to right, and we've just said our X is our input, so this has to be hours. And then our output is our cost. We can even fill in the verbal now. Our independent, that's our input. Well, that's hours. Our dependent is our output, and this is cost. To come up with the equation, we're going to use the verbal description. He charges $45 for the home visit plus $20 for every hour he spends working. So the electrician comes to your home, and even before he does any kind of work whatsoever, he's going to charge you $45. That is your beginning or your cost. Your beginning cost, I'm sorry. So our equation is our output cost. We begin with $45. Notice that is a cost. And then it says plus, this tells you we are going to add, is $20 for every hour. So $20, and our input is hours. So 20 times 8. Using this equation, we can now fill in our table. On our table, we have our hours is 0. So when hours is 0, we can plug into our equation to figure out what the cost is. It's 45 plus 20 times 0. 20 times 0 is 0. This is $45. Next one, H is 1. Let's figure out what our cost is. $45 we begin with, and then 20 times 1. So 45 plus 20 is 65. Now let's do a quick check. our rate of change, we figured from a table before, is if we take the difference of these two numbers. Let's see, 65 minus 45, that is a positive 20. It changed by a positive 20, which is what we have for our rate of change. So we know to go another hour, we're going to add another $20, and this will be 85. So when we plot, we're going to use our table. Our first plot, we're going to put our hours is 0 and our cost is 45. So on the x-axis we're at 0, but on the y-axis we're at 45. There's our first point. That's our beginning point. After 1 hour, it's 65. Notice how our x-axis is labeled. It's skipping the 1, so we're going to have to put a 1 in there. It goes 2, 4, 6. So 1 is somewhere between, halfway between 0 and 2. And we need to go up to 65. Put a little dot. That is going to be halfway between 60 and 70. And then last we have, after 2 hours, we're at 85. Now we can connect our dots. I would suggest using your ID to draw a straight line. This has completed our first problem. We have a verbal description. We used it to write the equation. We used the equation to come up with our table, and then we used our table in order to do our graph. In this case, we were given the verbal description first and was able to come up with everything else. Let's look at a second example. This time, notice in your verbal description we have blanks. You decided to start a savings account with a blank and want to add to it blank each month. We have a graph. I do notice that our x-axis is labeled and our y-axis is labeled. Our x-axis, that's our input, and our y-axis is our output, so I can fill in the independent. Independent goes with input. This is going to be the number of months. Output is the amount of money saved. That's our dependent, so amount of money saved. You can also look at our table. Our table also gives us our X, or our input, and our Y, or our output. We can use this table in order to fill in our graph. First, we're going to have to label our axes. Our inputs go from 0, 1, 2, 3, 4. So let's label the x-axis. There's 0, 1, 2, 3, 4. We can continue on 5, 6, 7, 8, 9, 10. Our y-axis, we need to go from 10 to 30. And we do have some 15s and 25, so let's go by 5. So this would be 5, 10, 15, 20. 25, 30, 35, 40, 45, 50. So when our number of months is 0, that's our x. The amount of money saved was 10. So x equals 0, y equals 10. Here's our first point. After 1 month, we have $15. After 2 months, we have $20. After 3 months, we have $25. And after 4 months, we have $30. Again, you can use your ID in order to draw a straight line. We want to figure out the equation. So figuring out the equation, it can be determined with the amount saved S after M months. Right, so amount saved, that's our S. M is going to represent our months. I'm going to put that on my table. When we write our equation, remember it is output is equal to where we begin, and then we may add or subtract from that, and it's the rate of change. So how are your Y values changing times your input? Our output is the letter S. We get that from our table as well as our graph. The beginning, how does this graph begin? We see on the table, when the number of months equals 0, we know we're going to start off with $10 saved. You can either get that from your from your table or from your graph. We read the graph left to right. There's our beginning point. Our rate of change, let's look at our table. From our first point to our second point, again on the outputs, we go from 10 to 15, that's a change of positive 5. From 15 to 20, that's a change of positive 5. 20 to 25, change of positive 5. And 25 to 30, a change of positive 5. Notice they're all the same, and so our output is changing by a constant rate of a positive 5. Then we need to multiply by our input. Our input is the letter M. We have come up with our equation. Now let's go back and fill in the verbal description. Some of you may have been able to do this sooner. You decided to start a savings account with the blank and want to add to it blank each month. So our first blank deals with what we began with. So you started the savings account with the amount of $10. That's our beginning amount. And you want to add to it, well, how much did we add to it each month? Let's go back to our table and we see we added $5 each month. So our first blank was our beginning, second blank was how much it has changed. This concludes topic 5-5, making connections.